Hello, welcome everyone. Today I'm Abhinav Kumar Shah,
I'm Sriram Pradeep.
and today we are going to present you on the topic document level text simplification using the Simpson approach. So we'll be going through the complete presentation and we'll be covering the following information: problem statement, related words, and the corresponding examples, a data set description, methodology, and the corresponding evaluation metrics to understand how well our model performs. So in our day-to-day life, normally we come across multiple set of documents for which we have to for which they require a domain knowledge, and it has its own set of complex vocabulary which are difficult to comprehend for a novice user. So our problem statement aims to solve the same problem using a set of aims to solve the same problem using for the document level simplification, and it aims to simplify the documents so that it becomes easy for a normal user to comprehend and to understand the details. So it has its own set of various challenges, which is basically we must not lose the important information that is present in the particular document, and the readability and the coherence of the complete information is also maintained. So it finds its usage in the multiple domains or the multiple areas where it could be used by the non-native speakers or persons with reading difficulties, or it could be used as a pre-processing step for the other NLP tasks like parsing, information extraction, text summarization, or the machine translation. So we're going through the example. So let's say there is a complex sentence and it goes through multiple stages to result into a final simplified sentence. First of all, the important keywords or the difficult complex words are identified, and the substituted words are then the substituted words which can be identified are identified, and then they are ranked, and then they are replaced so as to result a simplified sentence. Similarly, for these two examples, we observe that the simplified text doesn't lose any significant information while also maintaining the coherent structure in the complete text. And similarly, let's say those two previous examples for the text level simplification. In our current problem statement, we aim to solve the document level simplification, and let's try to understand how it is different from the text level simplification. In the complete article, the set of sentences pass on the coherent information from one sentence to the another, and so here we aim not to lose those information while also condense the complete article so as it is faster to read and the no information is also lost. So and it is different from the text summarization in the way that we are not aiming to do the abstractive or the extractive summarization or to find out the weightage of those sentences, but we want to replace the relevant information to replace the longer sentences or the longer set of sentences with a normal shorter condensed form, and then remove the irrelevant sentences which don't carry any information. Going forward to the previous work, so earlier the majority of the work was confined to only the sentence level simplification, and it was majorly the statistical approach, and a new SARI metric was introduced, or the people use reinforcement learning, or uses just a simple text to text transformer model, or they used as a tool, or they solved it like by creating a sequence to sequence architecture models. And for this document level simplification, a very less work was done, where basically the data set Wikilarge or the Wikidoc was recently developed, and a new metric DSARI was proposed by Sun for document level simplification.
We use two main datasets for training Simpson model, the Wikipedia and Wikidoc dataset. Both these are based on Wikipedia, but Wikidoc dataset has more extensive document level pairs. But the problem is Wikidoc dataset is more noisier compared to the Wikipedia, and we need to use some pre-processing techniques to clean these. One pre-processing technique is filtering, where if the initial sentence is of lesser length than the simplified text, we remove them. Other cases, realignment. If the initial text and the final text is different in terms of semantic similarity, those are also removed, and keyword is used to identify this issue. If basically we look at the distribution of issues in the dataset, this is the pie chart of the distribution. We have these issues that occur in the dataset. These are for examples of issues with the source and the simplified text. In the first case, as you can see, the length of sentence in the source is lesser than the simplified text. In the second case, it's talking about one person in the source text, but it is in the simplified text, it's talking about a different person, and we have a misaligned pair. The same thing with the third case, where it talks about a state called Adriana, but it talks about a Brazilian footballer in the simplified text.
approach, Simpson is enclosing a two-stage model for so as to solve the so as to get the simplified text. So in the two-stage process, but the first stage is the summarizer, which can be replaced by any pre-trained part of the T5 model, which aims to summarize the complex text to the less set of sentences, and the input IDs are passed to the simplifier, not the complete summarized sentence. So as in the set of back propagation, the summarizer or the simplifier would learn simultaneously at the same stage, and the information is shared and passed through in the complete back propagation step. So after the input IDs are passed from the decoder without doing any tokenizer, it is passed to again a pre-trained simplifier model, which simplifies the text and replace it with a more condensed form and simplified form of the text. So the generated output of the summarizer fed. So it is normally, and this complete architecture can be fine-tuned on the Wikidoc or the Wiki large datasets so as to improve further on the performance. And another approach, or the improved a further improvement on the existing approach can be done using the keyword prompting. So it has its multiple stages, where the first step is to extract the keywords, to identify the important relevant keywords, and then appending their weightage or the KW score to the initial sentences as part of the initial information, or use or attach as a complete those set of keywords in the initial appending it as a new sentence in the initial stage altogether, which is the KW separator. So these two separators can act as additional information so that the model can focus on not losing these relevant keywords.
Generally, for transformer models, we use cross-entropy loss. But in this case, we use an additional term called the cosine similarity of which basic cosine sim L-cossim. I'll talk about what this is, and an additional lambda parameter to control the importance of the L-cossim. A ReLU is used as the activation function for the model. So the additional term that we have, the goal of that is basically to simplify the text, but not make sure that the summarized text or the final text is different from the initial text that we have. So this uses the cosine similarity between the embedding of the last layer of summarizer and the embedding of last layer of the simplifier, and make sure that they are close enough. This is the overall architecture diagram. It takes in the input data. We pre-process the data using filtering and realignment. This is followed by summarizer, simplifier, which basically uses T5 or BART model. And finally, we have the summarized output. So this is the architecture diagram for the simplifier that we talked about just before, which uses the L-cossim.
So we have a multiple set of evaluation metrics so as to identify the model performance on making the sentence simplified. First is the SARI metric, which is a combination of the F1 score of the add, keep, or delete, and averaging them out. So it is the n-gram F1 score for the add operation, similarly for the keep operation and the delete operation. And the DSARI is a new metric which has been recently introduced, and it is as in the original paper, it's the average of the DSARI value of the keep, delete, or the add. And then there is a B score, which is a metric for the to understand how long or to penalize the longer translation of the simplified matrix. And then there is a FKGL score, which identifies how is the readability or the simplified text, how much readable it is, by giving it a score by which corresponds to how a US school grade level student will understand that particular set of simplified text. So we had used the following set of simplified matrix, those set of papers so as to compile this presentation.
Thank you.